So basically, we are going to be looking at how to solve variation of parameters. This method is basically method basically calculates the particular solution of the differential, or we can call it the particular function of the differential equation. So now, in this particular method, we'll be given two of the solutions of this homogeneous differential equation. Basically what we have been calculating on our like on our last videos. We did homogeneous differential equation, how to find the solutions. This is basically the two solutions of the differential equation. For example, y1 and y2 are the two solutions of this particular differential homogeneous equation. For example, in our last differential equation, we usually get c1 exponential x plus c2 exponential 2x. Now basically this is the solution of this differential equation. Now y1 here will be exponential x and y2 here will be exponential 2x. So basically this is what they mean. This is what it means by two solutions. These are the two solutions of this equation. Why this is the solution of this differential equation. So basically, to solve using variation of parameters, we're going to be assuming a particular variable here, the derivative of a particular variable times y plus v2, derivative of another variable v2 times, that's the first order of the particular variable times y2 equals 0, and we'll consider the same thing here, but in this case the y1 is differentiated, the y2 is also differentiated, equals the function of x given here, and the solution, general solution we are going to be obtaining using variation of parameters will be v1 y1 plus v2 y2. So let's get down to solving a particular question. To solve this by variation of parameters, now like I said, variation of parameters gives you a solution to particular equation. Now mostly variation of parameter question, they will give you the two solutions of this homogeneous differential equation. Remember we said that when solving homogeneous differential equation, you get the solution of the differential equation. For example, let me take this is a solution to a real and different root differential equation. For example, this is a solution to a real and different differential equation. Here this is the solution, but when they ask you to get the set of solutions, there are actually two sets of solutions in this, which is, like I said, which is y1 is equal to exponential m1x, you leave the constant, and y2 is equal to exponential m2x. So exactly like this, that is how they gave us the two set of solution for this solution. So taking y1 to be x and y2 to be x raised to the power 3. So the first step in solving variation of parameters, number one, is to express the equation into this form, which is my standard form of second order differential equation, which is p1 py1 py prime plus py equals 0, right? Sorry, equals a function of x. It's a function of x. So now basically we are given x raised to power 2 y prime minus 3x y prime plus 3y equals 4 x raised to power 7. So you can see this does not actually match. So dividing both sides by x square, dividing both sides by x square, and by x square, y prime minus 3 over xy prime plus 3 over x square y equals 4x raised to the power 5. So this is the equation we're going to be working with. Is that taken? So given my y1, my two set of solution, my y1 is what? X raised to x, and my y2, which is what? X raised to power 3. Now my second step is to follow this set of solution given by the formula, which says vy prime y1 plus v2 prime y2 is equal to 0, and vy prime times vy prime v1 times y1 prime plus v2 prime y2 prime equals the function of x. So my v1 prime, my y1, which is what? X, right? Plus my v2 prime, my y2, which is what? X raised to the power 3, right? Equals 0. And my v1 prime times my y1 prime, which is what? 1, right? Differentiating y1, which is y1 prime, which is 1, right? Differentiating y2, which is y2 prime, which is what? 3x raised to the power 2. So plus v2 prime times my y2 prime, which is what? 3x raised to the power 2 is equal to my function of x. My function of x here is what? 4x raised to the power 5. So solving the two equations, I take this to be equation 1, equation 2, I take this to be equation 1. So from equation 1, this is v1 prime x is equal to plus v2 prime x raised to the power 3 equals 0. Taking the other one to the other side, this is v1 prime x equals minus v2 x raised to the power 3. Dividing both sides by x, dividing both sides by x, my v1 prime is equal to minus v2 prime x raised to the power 2, right? So I can substitute this particular equation into my second equation. So now substituting this equation into my second equation, we have v1 prime plus v1 prime, which is my second equation, v2 prime 3x raised to the power 2 equals 4x raised to the power 5. So substituting this in this equation, I have minus v2 prime x raised to the power 2 plus v2 prime 3x raised to the power 2 equals 4x raised to the power 5. So vx prime 3x raised to the power 2 minus v2 prime x raised to the power 2, because these are like terms, so this will give me 2 v2 prime x raised to the power 2 equals 4x raised to the power 5, right? So now solving this, dividing both sides by 2x raised to the power 2, dividing both sides by 2x raised to the power 2, my v2 prime is equal to 2x raised to the power 3. Now, since we said my v1 prime is equal to minus v2 prime x squared, bringing my v2 prime into this equation, we have minus 2x raised to the power 3 times x raised to the power 2, which is equals to minus 2x raised to the power 5. So this is my v1 prime. Remember, the solution we are looking for is equal to v1y1 plus v2y2. So basically, we have my v2 prime and I have my v1 prime. Basically, what is left for me is to integrate them. So since I have my v1 prime to be equal to minus 2x raised to the power 5, integrating it to have my v1, I have v1 is equal to minus 2x raised to the power 6 over 6, which gives me minus x over 6 over 3. Is that taken? Solving my v2 prime, which is equal to 2x raised to the power 3, dividing both sides so that to get the value of my v2 becomes 2x raised to the power 4 over 4, right? So this gives me x raised to the power 4 over 2. So now, applying this into the equation I'm looking for, then remember this is your particular solution. Like I said, say it again, solving by variation of parameters only gives you your particular solution. So this is my particular solution. So remember, we already have our complementary function solving, since they gave me two roots of the differential equation, which gave me first root, which is x, and they gave me second root, which is x raised to the power 3 from the question. So your variation of parameters gives your particular solution. So now, like we said, we were given from the question. They gave us two sets of solution, x and x raised to the power 3. Now we said y1 should be one of the solution and y2 should be the other solution. So basically, let's continue, then we'll get back to this. Then we say my v2 is equal to x raised to the power 4 over 2. So given my particular solution, which is y is equal to v1y1 plus v2y2, my v1, which is what? Minus x raised to the power 6, right? Minus x raised to the power 6 divided by 3 times my y1, which is what? X raised to the power, my y1, which is x, right? Plus my v2, which is what? X raised to the power 4 over 2 times my y2, which is what? X raised to the power 3. So basically this gives me minus x raised to the power 7 over 3 plus x raised to the power 7 over 2. Taking the LCM, this is 6 in 3, 2 times this, that's minus x raised to the power 7 plus 6 into 3 times that, that's 3x raised to the power 7. So this gives me x raised to the power 7 over 6. So like I said, this is my particular solution. So remember, we are asked to find the general solution, and we said general solution is equal to complementary solution or complementary function plus my particular function. Now this is my particular function or my particular solution. Now to get my complementary function, since from the question they actually gave me two sets of solution, x and x raised to the power 3, and we said y1 is equal to x and y2 is equal to x raised to the power 3, then you know that complementary function of a second order differential equation. So the complementary function for a second order differential equation, the general, or we call it the implied function, will be y is equal to c1y1 plus c2y2, given a set of two solutions. This is the general solution to a second order differential equation. So since we are given my y1 is equal to x and my y2 is equal to x raised to the power 3, the complementary function will be equal to c1x plus c2x raised to the power 3. So my general solution g is now equal to my complementary function, which is c1x plus c2x raised to the power 3 plus my particular solution, which is x raised to the power 7 all over 6. So this here is my general solution using variation of parameters. Thank you guys for watching. Please subscribe.